In this journey, we will delve into the intriguing concept of the 11-dimensional model. This model, which extends beyond our conventional understanding of space and time, offers a new perspective on the fundamental forces and particles that constitute our universe. The advent of particle detectors like cloud chambers and bubble chambers provided humanity with an unprecedented window into the subatomic realm, allowing us to visualize the fleeting existence and intricate interactions of fundamental particles. These instruments, by rendering the invisible tracks of charged entities, have been instrumental in shaping our understanding of quantum mechanics and the fundamental forces that govern the universe. However, the interpretation of these events has largely remained confined to the familiar framework of four-dimensional space-time. The 11-dimensional model, with its expansive architecture encompassing a hierarchy of interconnected dimensions, offers a compelling and potentially unifying alternative perspective. This essay will explore how the 11-dimensional model can be applied to the particle reactions observed in cloud and bubble chambers, specifically focusing on how the introduction of a magnetic field and the resulting Lorentz force might be understood as the manifestation of a higher dimensional relationship within this intricate framework. To appreciate the potential of the 11-dimensional model in this context, we must first revisit its core architecture. Beyond the three spatial dimensions and linear time, the model posits 7 additional dimensions that influence the fundamental properties and interactions of particles. The fourth dimension is intricately linked to rotation, the engine of temporal evolution. The fifth dimension embodies polarity, the inherent duality and directional nature that governs entities. Dimensions 6 and 7 govern the dynamics of two-body systems, introducing orbital motion and the relative orientation of polarities. Dimensions 8 and 9 extend this to three-body systems, incorporating the complexities of hierarchical motion and multi-layered polarity interactions. Finally, the 10th and 11th dimensions represent the overarching cosmic context, with expansion and a fundamental interconnectedness weaving the fabric of the everyverse. When a charged particle traverses a cloud or bubble chamber, its journey through the familiar three spatial dimensions is made visible through the ionization it leaves behind. The fourth dimension, time, dictates the duration of this observable existence within the detector. The particle's intrinsic properties, such as spin and charge, align with the fourth and fifth dimensions respectively. However, the introduction of a magnetic field into the chamber, a common technique used to analyze the particle's momentum and charge, fundamentally alters its trajectory, causing it to curve due to the Lorentz force. It is this interaction, the emergence of a curved path, that we can explore as a manifestation of higher dimensional relationships within the 11-dimensional model. The Lorentz force, a cornerstone of classical electromagnetism, describes the force exerted on a moving charged particle within a magnetic field. This force is perpendicular to both the particle's velocity and the magnetic field, resulting in a curved trajectory. Within the 11-dimensional model, the introduction of the magnet and its associated magnetic field can be seen as the addition of another body to the system, a macroscopic entity interacting with the microscopic charged particle. This interaction, occurring between two distinct entities, falls under the domain of the 6th and 7th dimensions, which govern two-body systems. The 6th dimension, representing the orbital motion of two bodies, can be analogously applied to the particle's curved path within the magnetic field. While not a stable, repeating orbit in the classical sense, the continuous deflection of the particle by the Lorentz force can be viewed as a dynamic orbital relationship between the particle and the magnetic field. The particle is forced into a trajectory that is constantly changing direction under the influence of the field, akin to a celestial body being gravitationally bound to another. The 7th dimension, describing the tilt of orbital planes in a two-body system, might manifest in the specific three-dimensional geometry of the particle's curved track within the bubble chamber. The orientation of the magnetic field relative to the particle's initial velocity and the resulting plane of its curved motion could be seen as defined by this seventh-dimensional relationship. The helical paths often observed for particles entering the magnetic field at an angle to the field lines further illustrate the complex three-dimensional geometry arising from this interaction. The fundamental force of electromagnetism, responsible for the Lorentz force, itself finds a potential grounding within the 11-dimensional model. The interconnectedness of the higher dimensions, particularly the 11th, might mediate the electromagnetic interaction between the charged particle and the magnetic field. The particle's charge, a manifestation of polarity in the fifth dimension, interacts with the magnetic field, a macroscopic expression of electromagnetic forces arising from higher dimensional dynamics. The resulting curved motion, governed by the Lorentz force, becomes a tangible manifestation of the dimensional relationship established between the particle and the magnet within the 11-dimensional arena. Furthermore, the energy and momentum of the charged particle, intrinsic properties linked to its movement and rotation within the fourth dimension, and influenced by the overall cosmic context of the 10th and 11th dimensions, dictate the radius of curvature of its track in the magnetic field. Higher momentum particles, possessing a greater inertia within the 11-dimensional space, exhibit a larger radius of curvature, while lower momentum particles follow tighter spirals as they lose energy through interactions with the chamber medium. In essence, the introduction of a magnet into a cloud or bubble chamber and the resulting Lorentz force acting on charged particles adds a crucial layer of complexity to the system, necessitating the involvement of the dimensions governing two-body interactions within the 11-dimensional model. The curved trajectories we observe are not merely particles moving through a static four-dimensional space-time under the influence of a force, but rather a dynamic interplay within a higher dimensional reality, where the fundamental properties of the particles, the nature of the electromagnetic force, and the geometry of the multidimensional space all contribute to the intricate and visually revealing events captured within these remarkable detectors. Beyond the initial 7 dimensions that provide a foundational understanding of particle properties and two-body interactions, the 11-dimensional model posits further layers of complexity that could influence the natural reactions observed in particle detectors. The 8th and 9th dimensions, governing 3 body systems and the intricate modulation of their polarities and orbital dynamics, become relevant when considering events involving multiple interacting particles within the chamber. A single incoming particle often collides with atoms of the detector medium, creating a cascade of secondary particles, each with its own trajectory and properties. The precise angles and momenta of these outgoing particles, seemingly governed by conservation laws within our three-dimensional space, might also be subtly influenced by the constraints and freedoms afforded by these higher many-body dimensions. The seemingly random nature of decay pathways and the branching ratios of different particle products could be a reflection of the energetic landscape and allowed transitions within the 11-dimensional space, with the observed outcomes being the projections of these higher dimensional evolutions onto our limited perception. The 10th dimension, representing the deterministic force of cosmic expansion, provides the overarching backdrop against which all these particle interactions unfold. While its influence on the scale of a cloud or bubble chamber event might seem negligible, this fundamental stretching of space-time could subtly affect the intrinsic properties of the particles themselves, influencing their lifetimes and decay rates. The 11th dimension, embodying cosmic contraction and the ultimate interconnectedness of the universe, might play an even more profound role. As the potential origin of gravity and a conduit for instantaneous information transfer, the 11th dimension could be the arena where the fundamental forces governing particle interactions are ultimately unified. The electromagnetic force responsible for the Lorentz force, the strong and weak nuclear forces governing particle decays and transformations, all might be different facets of a single underlying interaction mediated through the higher dimensional fabric and the interconnectedness of the 11th dimension. The beauty of applying the 11-dimensional model to these particle physics experiments lies in its potential to offer a more holistic and interconnected understanding of phenomena that currently appear disparate. The seemingly simple act of a charged particle curving in a magnetic field, a well-understood consequence of the Lorentz force within classical electromagnetism, could, within this expanded framework, be a manifestation of a deeper, multi-dimensional relationship governed by the geometry and dynamics of a higher dimensional reality. The particle's charge, linked to the fifth dimension's polarity, interacts with the electromagnetic field, whose existence is rooted in the higher dimensions, leading to a motion that maps the particle's state onto the dimensional relationships defined by this fundamental force. However, it is crucial to reiterate that this application of the 11-dimensional model to particle physics experiments remains largely within the realm of theoretical speculation. Developing a rigorous mathematical framework capable of quantitatively predicting the observed particle behavior based on the 11 dimensions is a monumental challenge. Furthermore, direct empirical evidence for these extra dimensions and their influence on particle interactions is still lacking. The current standard model of particle physics, operating within four-dimensional spacetime, provides a description of the fundamental particles and forces we have observed, but it is only a piece of a larger puzzle. Any extension to higher dimensions must not only explain the existing data, but also offer novel, testable predictions that can be verified through future experiments. Nevertheless, the exercise of considering these well-established experimental results through the lens of the 11-dimensional model can be a valuable tool for stimulating new ways of thinking about fundamental physics. By challenging our assumptions about the dimensionality of spacetime and the nature of fundamental forces, we might uncover deeper connections and ultimately move closer to a truly unified understanding of the cosmos, from the smallest quantum fluctuations to the grandest cosmic structures. The particle tracks etched within the transient mists and bubbles of these detectors could be far more than mere visual representations of motion. They could be subtle clues hinting at the hidden architecture of a universe woven from 11 interconnected dimensions. Thank you for exploring the 11-dimensional model with us. If you enjoyed this journey through the cosmos, please like, share, and subscribe. Your support helps us grow and bring you more fascinating content.